alive!
Welcome back to the workshop, everyone. Glad you could join us for part 6 of the Tube Preamp Pedal Build. We made a lot of good progress in the last video. We got the power supply installed, we made all the connections for the high voltage, we got the tube filaments wired up, we installed the input board and the boost board. Now, one of the things I forgot to mention in the last video was that I actually had to make a little change to the boost circuit. The MOSFET that I was going to use was a BS170, which comes with 2 different pinouts. And I can never remember which one I have, so I just left it socketed so that I could flip it around if I needed to. And it's a good thing that I did, because I had forgotten how little gain that MOSFET had available. And so the amount of gain I was getting out of the boost circuit was probably enough for the rhythm channel. On the lead channel, it would not have been enough gain. The reason is the lead channel has more distortion available, and as the signal distorts, it obviously compresses a lot. When you run a boost into the front end of a very compressed signal, you need a lot of boost to hear any difference. So the amount of gain that I would have gotten from that BS170, you probably wouldn't have heard any difference when you switch it on and off. Fortunately, the 2N5088, which we've been using for our switching circuit, has a lot more gain available, and it's a pretty decent sounding transistor. Now, the reason that I initially decided against a 2N5088 or any other bipolar transistor for the input boost is that I don't want to get any bipolar transistor distortion when we really crank that boost all the way up, because it's not a very pleasant sound. But as I was thinking about it more, typically when you build something like that into a pedal, like when you're just building a single transistor clean boost pedal, you're only running it off of 9 volts, maybe 18 volts. In this case, we've got about 30 volts to work with, so that transistor should have plenty of headroom. Now, hopefully we'll make a lot of good progress in today's video too, because there's a lot that still needs to be done. Because I wasn't sure which switches I was going to be using for the foot switches, I didn't drill out the holes yet. I didn't want to end up having them too big for the switches that I chose and then having a lot of play in there. So we'll have to drill those out. We'll drill out the holes for the LEDs. We're going to wire up the boost pots. We're going to make all the connections on the switching board, including the connections to the foot switches. And then we'll go through and test every single transistor switch and make sure that it's functioning properly. Once that's done, then we get to the fun part, and we can start installing the core preamp circuit, wiring up all the tubes, and we get to really see everything come together then. So, let's get started. Well, it was a little more difficult than I expected to get this switch in here. I knew it was going to be close to the transformer. It's very close. Fortunately, we don't have to worry about any interference from the proximity to the transformer, because the only thing this switch is doing is turning on and off the transistor on our switching board that activates or deactivates our boost. So that won't cause any issues. You may have also noticed on this bicolor LED, the one in the middle here, these LED bezels are not made for bicolor LEDs, so there wasn't quite enough room in there, and if I hadn't bent those leads inward and insulated them, then they probably would have grounded out against the bezel. So I had to bend them a little bit, secured them in place with some hot glue, no big deal. Anyway, those are in place, so let's finish the connections on our switching board. So in the last video, I briefly talked about the importance of getting a good mechanical connection before you solder. I had an electrical problem at my house a couple days ago, where the entire upstairs would just lose power, and then after either a few minutes or a half an hour, it would come back on again. Turns out the entire upstairs in our house is on a single circuit breaker. It's a small house, so it only needs one breaker for the upstairs. I measured the voltage at one of the outlets when the power was off, and I was getting 0.12 volts or something like that. So I knew that it was a bad connection somewhere. So I had to go up into the attic and crawl around and, move insulation all over the place and get sweaty and itchy and grimy, and I needed to find out where the first stop was after that wire left the breaker panel. And it turns out it was one of the light switches in an upstairs bedroom. I pulled the switch out. I was starting to pull out the neutral and hot wires to check just to see if I could spot any problems with it. And as I was pulling out the neutral wires, I pulled the wire nut right off. It was barely hanging on there. Someone had used the cheap, soft, rubbery wire nuts. There's really nothing wrong with those per se, but if you're going to use those, you really need to make sure that the wires are twisted together, because you just can't crank on those the same way that you can on the hard plastic ones. When you use the hard plastic ones, you can really, turn it hard and it'll actually twist the wires together inside the wire nut. But in this case, that didn't happen. They were perfectly straight and just barely secured by that wire nut. So I used my lineman's pliers, twisted them together real good, and then put a different wire nut on there, made sure that that was nice and tight, and I haven't had any issues since. Now the point of saying all this is that we have to think about mechanical connections the same way when we're working with this stuff, especially when it's high voltage. When we're soldering something, if it doesn't have a good solid mechanical connection, over time vibration will cause cracks in the solder. And in fact, one of the channels that I like to watch is D-Lab. If you haven't checked it out, go search for D-Lab. The guy's got a lot of really cool videos. And in one of the videos that I watched recently, he was fixing an amp that had several cracked solder joints, and it looks like a little ring around the solder joint. That will happen if you don't have a solid mechanical connection. So anyway, just wanted to bring that up again. It bears repeating that if you're working with really critical connections like this, you need to have a solid mechanical foundation before you put the solder on. Anyway, we'll get back to the build. Well, as I was looking at my work here, I realized that I connected these switches completely wrong. I'm supposed to be switching the control voltage leg, not the ground leg. So I'm going to have to undo a lot of these connections and redo all of this. I also don't like the way that these shielded cable connections turned out. So I'm just going to tear all of this out and redo it. Okay, I've gotten rid of all of the bad connections here. Now I'm going to reconnect these switches the right way. And then I'll go through the schematic with you and explain what I did wrong. And maybe give you a better understanding of just how this whole switching setup is supposed to work. Alright, I think I've found a good place to stop for the day. The brain fry is starting to set in, so it's time to call it quits. But here's a shot of what I got done so far. I tried to clean up the wiring as much as I could. The black wires that you see laying across the turret strips there, those are just the ground wire for the shielded cable. Those will be grounded to the nearest ground point on the turret strips. So I wanted to explain what I had mentioned earlier, that when I screwed up the switching and I had to take it apart and redo that. Okay, so here's a schematic of the switching board that we're using here. First of all, look at where the power comes in, the 5.1 volt in on the right of the schematic. that is feeding the control voltage to both of those PNP transistors. Now the reason that we're using PNP transistors here, in this case it's 2N5087s, rather than the NPN transistors that you see everywhere else in this schematic, is because this is a high side switch. You can't use an NPN transistor like a 2N5088 as a high side switch, because in order for it to be used as a switch and current to flow through it, the base has to be pulled at least 0.7 volts more positive than the collector. So in this case where the voltage is coming in, there's no way to do that. The load comes after these transistors. So we use a PNP and we're able to use it as a high side switch. And then everywhere else you see the NPNs, those are a low side switch, because the transistor is tied into ground, and then whatever we're connecting to ground is coming in above that transistor. You notice on the boost function here, I've actually got a second transistor switch that cuts off both of the other boost transistor switches. Now the reason I do this is so that when you turn the boost on and off, it doesn't matter what channel you're on, it'll cut off both of those boost transistor switches. And then if you look at the channel switch, it's labeled rhythm and lead. Depending on what switch position that mechanical switch is in, it'll either supply control voltage to the rhythm channel or lead channel. And of course we've got the blue end and yellow end of that bicolor LED tied into one leg or the other, so that as you send the control voltage to the lead channel, the lead LED lights up. So what I did before was, and the reason that I had to undo it and rewire this was that I had actually wired the ground to the switch, and so I was sending ground to all of these transistor switch bases instead of sending a control voltage. It wouldn't have functioned at all if I had left it that way. So anyway, all of the switching is wired up now, and tomorrow I'll come back and I'll work on... What am I going to work on? Oh, then we'll connect all the ground points together and start installing all of the components for our core preamp circuit. Okay, back again. Time to get those ground wires done. Alright, I've made all of the ground connections now. I actually made the same mistake again that I made before.
What?
I had both sides of this LED connected to ground instead of connecting the control voltage there, so fixed that. But this is why we always double check our work. So now I'm ready to check all the ground connections and recheck the high voltage connections to make sure we don't have any short circuits there, because I did, I pulled out the power supply board and wired, put an extra wire on there, so I just want to make sure that I didn't somehow mess anything up there. You can be 100% confident in your work and still find mistakes, and I'd rather not find those mistakes the hard way. And I've just got a tone setting on the multimeter here. Here's our high voltage lines, no short, no short, no short. And here's our control voltage. Okay, that's definitely not a short. Okay, so now all the ground points where I should have a good ground connection. So that side of the switch. Okay, that works. Good. Come on. Okay. Okay, so it looks like everything's good there. 359, 382, 385. Nothing smells hot, that's good. And our control voltage is 5.14 volts. So we're good there. So that means right now we should have a red LED on right now. And we do. All three of our LEDs are lit up. That's good news. And there's our bypass. So you can see all three of them turned off when you hit the bypass switch. This is our channel switch. Goes from blue to yellow like it should. And our boost switch. So it looks like everything's working. So I'm pretty happy. Well, I'm going to have to stop there. I kind of run out of time this week. I would have liked to get a little bit more done. I'm sorry we couldn't move further with this. But it is so satisfying after all of that work to finally see this come to life, see that, everything light up. I'm going to take this home to my daughter because she loves making the lights go on and off. It's every time I make something new, I'll bring it home to her, and she just loves hitting the switch and watching the light turn on and off. So the only part of the preamp that's functional right now is the input buffer and the boost stage. So basically, I hold in my hands the world's most expensive clean boost pedal. But, it looks cool, so I think somebody would pay $1,000 for it, right? Yeah, like I said, I wish we could have gotten a little bit further this week. That just means we'll have even more fun stuff to do in the next video. That's the end of this video. Like it if you like it, comment and subscribe, and we'll see you next time.